Math 70, section 6.7, which is modeling and solving problems with quadratic equations. So these are equations that have a degree of 2. So there's several different applications that you're going to use in this section. And we learned how to solve quadratic equations. And these are problems that involve real life situations. For example, projectile motion. A child is on a cliff that the cliff is 240 feet above sea level. And this is the nice little picture of this situation. And the height of the cliff is 240 feet above sea level. We want to know, when will this ball that this child is going to throw, when will it reach 240 feet? So it's already at 240 feet. So how many seconds is that? That's 0 seconds. So you have this equation. It's h equals negative 16t squared plus 32t plus 240. This equation is given to you. In classes like pre-calc, you're going to be asked to create this equation. But for now, this is the equation you're given. So t represents the time at which it reaches this height. So in the first question, they want to know, when will the ball reach 240 feet above sea level? So we want to know when the height will be 240 feet. Well, common sense says you're already at 240 feet. So when is for sure going to be 0 seconds, okay? But let's prove that. So you're going, because the height that they're asking you to find is 240. So you replace 240 for height. Time is what we're looking for. So we use the method that we learned in section 6.6. To solve quadratics, you want to have a 0 on one side. So I subtracted 240 from both sides. What's happening here are these numbers are going to cancel. So you have negative 16t squared plus 32t. Now, remember, the very first thing you're always going to try when you solve these equations is factor a GCF. Negative 16t can come out of these two. So you're left with t minus 2. Now, the zero product rule says you're going to set each of these quantities equal to 0. Divide by negative 16, and t is 0. Add 2, and t is 2. So the time in seconds where this ball is going to be thrown up in the air, and when will it reach 240 feet? It's at 0 seconds, which that makes sense. You're above 240 feet above sea level. And it's going to go up, and 2 seconds later, it's going to reach 240 feet. So these are the two answers. Okay. Next problem. We have a hallway. And this hallway is in the shape of a rectangle. And we know that it says the length of the rectangle hallway is 3 feet more than twice the width. So it's twice the width plus 3 equals W. Sorry. So the width we don't know. We're going to call it W, but the length is 2W plus 3. We know that the area of this is 44 square feet. So again, width we don't know, but the length is 2W. It's twice that plus 3. So now area is length times width. So we're going to multiply W times 2W plus 3 equals 44. Again, in section 6.6, you learn you have to distribute. So 2W squared plus 3W equals 44. Subtract, we want to get a 0 on one side. And we have to use trial and error or guess and check. So what two, I'm sorry, not trial and error and guess and check. Trial and error and guess and check are the same. Trial and error and the AC method. So what two numbers, I'm just going to use trial and error. What two numbers multiply to give you 2w squared? So we'd have to have 2w and w. And then I need two numbers that multiply to give me 44. And you have to make sure you put them in the right spot. So it looks like this. To make this video go quicker, I'm just going to tell you. So 11 times negative 4 is negative 44. But if you outer and inner them, you get negative 8 plus 11 is positive 3. So once you set these two equal to 0, you get w equals negative 11 over 2. Remember, it's the opposite of this over that, and also 4. Now you're going to throw this answer out. Throw it out because you can't have, we're looking to figure out what numbers I can put in here to make the product of these equal to 44. I can't have a negative, I can't say my hallway is negative 11 halves feet long, but I can say 4. I can use this answer, 4. So I'm going to put 4 in right here. And 4 times 2 is 8. 8 plus 3 is 11. So the dimensions of this rectangular hallway are 4 by 11 feet. And if you think about it, 4 times 11 is 44. Another example is we have a triangle. And if you read the problem carefully, it says we have a triangle. And it says the height is 5, here's the height of the triangle, it's 5 inches less than the length of the base. So we don't know what the base is, but the height is 5 inches less than the base, so it would be b minus 5 for the height. It says the area is 42 square inches. So area of a triangle is 1/2 times the base times the height. So let's plug in everything we know. Well, the base is b, the height is b minus 5, and the area is 42. Now we have to solve this. I don't like this 2 here, so I'm going to multiply both sides by 2. 84 equals, these 2's cross out, we have b times b minus 5. I'm going to distribute this b squared minus 5b equals 84. And I'm going to bring this 84 over here and set it equal to 0. Now this 84 will become a negative 84. Now I have to think of what times what is negative 84 but adds to be negative 5. So I know I have b and b. So I want to think of two numbers that multiply to give me negative 84. And that would be negative 12 and 7. Why I'm using those? Because they add to be negative 5. They multiply to give you negative 84. Then you set each of these equal to 0. So b could be 12 or it could be negative 7. But I'm going to throw out negative 7 because I can't have negative base. But I can have, this is 12. And if I plug 12 in here, 12 minus 5 is 7. So this is a 12 base, height is 7 triangle. Okay. Example number 4. We are using the Pythagorean theorem. The Pythagorean theorem says that when you have a right triangle, 90 degrees, the side opposite is your hypotenuse. And these are your legs. These are the legs. And the Pythagorean theorem says if you square the legs, it's equal to the hypotenuse squared. So in this problem, it's one of the legs is x plus 7, another leg is x, and 13 is your hypotenuse. So we're going to use the Pythagorean theorem. We're going to square each side, each leg, I should say, and you set it equal to the hypotenuse squared. So x squared plus, if we FOIL x plus 7, you get x squared. 7 and 7 is 14x plus 49. And 13 squared is 169. So we want to collect like terms, and we want to get a 0 on this side. So x squared plus x squared is 2x squared. If I subtract 169 from 49, I get negative 120. And now I see that I have a 2 I could take out, a GCF. Okay. Now I want to factor. What times what is x squared? That's easy, x times x. And what times what is negative 60 but adds to be 7? So that would be negative 5 and positive 12. And now set each of these products equal to 0. So 5 and negative 12 are our possible answers. But I'm going to throw out negative 12 because I can't have a negative dimension. So 5 is good. So one of the legs is 5. And 5 plus 7 is 12. So this triangle is 5 by 12. 5 plus 7 is 12. Okay, last example. We have a TV, and it's a 20-inch TV, and it's rectangular in shape. TVs are measured, their dimensions are measured by the diagonal. So in other words, here's your rectangular TV. The diagonal would be that right there. So we have a 20-inch TV. We want to know, is this TV going to fit in to this media center cabinet? Okay, so it tells you that it's measured diagonal. It's 4 inches wider than it is tall. So we don't know that measurement, but we know this is 4 inches wider, x plus 4. So now we have the Pythagorean theorem. So this is what you have. You have a rectangle, a triangle. It's a 90 degrees. Your hypotenuse is 20, and your dimensions are like that. X and x plus 4. So again, this is a Pythagorean theorem application. We're going to square the legs. So x squared plus x plus 4 squared equals 20 squared. And I'm going to FOIL this out, and I'm going to get x squared plus 8x plus 16 equals 400. 20 times 20 is 400. So we have 2x squared plus 8x plus 16 equals 400. And now I have to subtract 16 from, or 400, subtract 400. Okay, so 2x squared plus 8x minus 384 equals 0. Now I'm going to factor out, a 2 comes out of this. Okay, let me make sure. 384, yep. I'm going to pull 2 out of all these 3. So factor out a 2, you're left with x squared plus 4x minus 192. And you have to factor this. What times what is negative 192 but adds to be 4? And it's 16 and negative 12. So again, you don't need that. That's not part of, we want these two because these two have variables. Set each of these equal to 0. So x can be negative 16, remember it's the opposite of this, or 12. I'm going to throw this answer out because it's negative. I'm going to use 12. So the dimensions would be 12 here, and 12 plus 4 is 16. So this is a 12 by 16. These are the dimensions right here. So the question is, the television screen is 16 inches wide, so it will fit in this new cabinet. That's the width of it, 16 inches. We want to make sure it's less than 20. That concludes 6.7.